Hey everybody, it's Miss Berry. In today's video, we're going to be going over what I'm calling section 2.2, which is proofs using triangle congruence. Alright, so this section is all proofs. So just take a moment, prepare yourself. You can do this. You are totally capable of doing this. It is going to be hard, and we're going to work through it together. And the more you do these, the better you're going to get at them. I promise. All right, so let's think back to our last section that we were covering. We talked about those four postulates and width, side, 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 angle, side, angle, and angle, side. We know how to use those three congruent parts of two triangles. So three sides, two sides and an angle, two angles and a side, and then two angles and a side. So that's what I'm referring to when I say the three congruent parts. And we talked about yesterday, or whenever you watch that video, we talked about in section 2.1 that when we're proving that triangles are congruent, there's always going to be two triangles, right? So that's what we're talking about when we say the three congruent parts. That's referring to each of those sides, with the two sides and the angle, the two angles in the side of two triangles. Alright, so we know how to use three congruent parts of two triangles to show that the two triangles are congruent. We have done some proofs where we have used those three congruent parts of two triangles to prove that they're congruent. And once we know that the triangles are congruent, so once you have proven that, then we get a lot of information for free. We now know that the other corresponding parts of these congruent triangles are congruent. So with the sides, whenever you prove that two triangles are congruent with side, 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 guess what? You also get that the three angles are also congruent. All right, so for example, here with this diagram at the bottom, let's say that we've proven that these two triangles are congruent. Let's name these triangles and see which parts are congruent to what. All right, so you want to start when you're naming triangles, you always just start by randomly naming one of them. All right, so I'm going to name this one on the left triangle A, B, C, just putting that one in alphabetical order. Now I'm going to match it up with this triangle on the right. All right, so angle A is the angle that's in between. Sorry, I forgot you couldn't see where I was pointing. Angle A is the angle that's in between the side with two tick marks and three tick marks. All right, so here's the side with two tick marks and three tick marks. So A corresponds to X. All right, so let's start naming this one over here. Triangle. We said that A corresponds to X. Let's figure out what B corresponds to. All right, so B is the angle that's between these two sides here. So the side with two tick marks and one tick mark. All right, so here's two tick marks and one tick mark, so that's Y. All right, so B corresponds to Y, and that just leaves Z to correspond to C. All right, so let's talk about this paragraph here and how it relates to the diagram at the bottom. All right, so what postulate would you be using to prove that these two triangles are congruent? What information are you given here? You're given the side, 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 right? All right, so if you write a proof and you prove that these two triangles are congruent, then for free, once we know that those triangles are congruent, we now know that all the other corresponding parts of those triangles are now congruent. All right, so for example, we now know that angle A is congruent to angle X, angle B is congruent to angle Y, and angle C is congruent to angle Z. All right, so you get a lot of information by proving that two triangles are congruent. Now, because that concept is so important and so useful, we have a name for it. So this is our abbreviation for when we use that concept in a proof. It's CPOCTAC. I usually call it CPOCTAC. Unfortunately, there's not a better name for this. more catchy name for it. But CPOC-TAC stands for corresponding parts of congruent triangles are congruent. All right, so corresponding parts of congruent triangles are congruent. So that's what CPOC-TAC stands for. All right, so if we are using that concept in a proof, once we have proven that two triangles are congruent, and then we want to use the fact that now we know that all the corresponding parts are also congruent, we're going to abbreviate that as CPOC-TAC. All right, so we're going to start, before we get into the proofs, let's just start with some easy questions. Here we have two triangles. You can see they're kind of overlapping. It says the triangles, triangle HKL and triangle MKJ are congruent. Identify their common side or their common angle. All right, so I want you to look at this diagram and see if you can identify what do these two triangles have in common. Do they have a common side? Do they share a common side? All right, so I'm looking at triangle HKL first. All right, just kind of outlining that so you can see there's that triangle. I don't think it shares a side, right? It shares like a portion of a side, but it doesn't share like an entire side with the other triangle. And let's look at this one. What we say, MKJ. All right, so MKJ. All right, so yeah, again, it shares a portion of a side with the other triangle, but not an entire side. So a common side, they do not have a common side. All right, so maybe they have a common angle. Do you think these two triangles have a common angle? All right, so here I've highlighted them. Can you see the angle that they share? I mean, you might can see just by looking at the name. All right, so you see they both have the angle K in the middle. So that's the what they have in common. They share a common angle, which is angle K. All right, let's look at one more. All right, so this one says, separate and redraw the indicated triangles. Identify any common angles or sides. All right, and the two triangles here are, the two triangles in question are triangle QSR and triangle TSR. Right, so you can kind of, you might can make a guess here just based on their names, but let's follow the directions. There's triangle QSR. There's triangle TSR. Do you see that they share a common angle or a common side? They don't have an angle in common, right? Because QSR, that's a big angle. That angle R right there, it's almost a 90-degree angle. And then for TSR, same thing over here. This angle S, it's almost a 90-degree angle. The angle S for QSR is very small. It's an acute angle right there. All right, so this time they do not share a common angle, so we'll mark that out. No common angles. But they do have a common side, right? That at the very bottom, you can see they share that entire side. All right, so they share the side SR, so the line segment SR, the side SR, or RS, whatever you want to call it. I think I just called it SR because that's how they named it in the triangle. All right, so let's get into our first proof. All right, so here you can see we have a diagram. The diagram is already marked for us. That's really nice. That just saves us a little bit of time whenever we don't have to do that. It says we are given the angle ABD is congruent to angle CBD. So ABD is congruent to CBD. Right, so that's those two angles there. They've already got them marked for us. And then we're also given the angle BDA is congruent to angle BDC. All right, so BDA is congruent to BDC. All right, so those are also marked as congruent for us. All right, I'm seeing one more thing. Do y'all see they have this little piece in the middle in common, right? They share this side BD. All right, so I'm going to mark that. I'm going to go ahead and mark that and put a little tick mark there. They've got that side in common. All right, so without looking at the proof, if you were going to prove that these two triangles are congruent, what postulate do you think you would use? So just ignore the triangle on the right. Let's look at the triangle on the left. We've got two angles and an included side. Two angles and an included side. So that would be angle, side, angle, right? So that's kind of what we have in the back of our mind. We're thinking this is probably an angle, side, angle problem. All right, so let's look at what we're trying to prove here. So we're trying to prove that side or line segment AB is congruent to line segment CB. So that's up here at the top. We're trying to prove that AB is congruent to CB. All right, so one way that we can do that is to prove that the triangles are congruent, and then we'll use that CPOC tag, which is corresponding parts of congruent triangles are congruent. So our approach here, is going to be prove the triangles are congruent. So if we can prove that the triangles are congruent, then we can use CPOC tag to prove the AB, side AB is congruent to side CB. Sorry for the sloppy handwriting. Okay, so that's going to be our approach. We're going to try to prove that these triangles are congruent. Then we're going to be allowed to use CPOC tag, which is going to allow us to quickly prove that corresponding parts of congruent triangles are congruent. Okay, so first line, we're looking at our proof down here. For some reason, students seem to prefer this type of proof where all the reasons are blank. I like the ones that go side to side. Like to me, I think that's that one's a little less challenging in my opinion. But students seem to prefer this where all the reasons are blank. So I try to throw some of those in on our homework and stuff like that. All right, so it says line 1. Angle ABD is congruent to angle CBD, comma, angle BDA is congruent to angle BDC. Well, that was given to us. That was what was given. All right, so that was given. All right, next line. Side BD is congruent to side BD. All right, so we already marked that. We marked that earlier. But do y'all remember what property that is when something is congruent to itself? That's the reflexive property. You're going to see the reflexive property gets used so much. So that's definitely one that you are going to get so used to using it, you probably won't even have to put it on your formula sheet. All right, and then our next line says triangle ABD is congruent to triangle CBD. All right, so triangle ABD is congruent to triangle CBD. Remember, when we're trying to prove that two triangles are congruent, we're always going to be using one of our four postulates. So either side, 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 angle, side, angle, side, angle, or angle, angle, side. All right, so we already said up here earlier, we said, well, if we're going to have to prove that these are congruent, let's go ahead and identify which postulate it is. And we said that it's definitely angle, side, angle, because it's two angles. And remember, when we're doing this, we are just ignoring this triangle over here. Whoops. We are just totally ignoring this triangle. So don't even look at that. All right, we're just looking at this triangle on the left. All right, so just looking at one of the triangles. And then we're saying, okay, what do I have marked here? And I've got two angles marked, and I've got the included side. All right, so that's angle, side, angle. All right, so remember, if you are still, if you're still feeling a little bit rusty or maybe just not confident about the four postulates, figuring out which is the one that we're using, have those laid out in front of you. All right, so put those all on a little index card, draw a picture for each of them, write the definition, so and then have them laid out all in front of you. That way, whenever you are writing these proofs, you have that to reference. All right, so we said that this is angle, side, angle postulate. And I'm not picky on this. I don't care if you write angle, side, angle, or if you write angle, side, angle postulate. So either way is fine. If you just write ASA, that's fine with me. All right, and then last line, side AB is congruent to side CB. All right, so AB, look at how the triangles are named. AB, CB. Perfect. That we're going to get that for free by CPOC-TAC. All right, so because corresponding parts of congruent triangles are congruent, that means that this side AB is congruent to this side CB. All right, so easy peasy. You're going to see this kind of general outline take shape on a lot of these proofs. So the first kind of, the majority of the proof at the beginning will be spent proving that two triangles are congruent, and then the very last part of the proof will be the CPOC-TAC. All right, so here we have a little bit more of a challenging proof, definitely a little bit, it's about a little bit over twice as long as the last proof. And we've got some, kind of notation that's maybe just fresh on your mind. You haven't really got it all memorized yet. That's okay. This is not something that I would expect you to do on your own, like on an exam or something like that. But this is a great resource to study with. This is something, that I would love for you to go back later and try this on your own without looking at the notes, but without looking at the proof that we wrote together. Because if you can complete this proof on your own, then you are going to be totally fine when it comes to the exam. All right, so let's read over what we're given, what we're trying to prove. We'll take a look at our diagram and then we'll start the proof. All right, so it says complete the proof. You're given that line L, right, so that's what that symbol means. The little cursive L means line L is perpendicular to, right, so that's what that symbol means, is perpendicular to. And remember, when we say perpendicular, I want you to think right angles. Remember, when two lines or line segments, when two lines or line segments are congruent, when two lines or line segments are perpendicular to each other, they form a right angle. All right, so line L is perpendicular to the line segment AB. All right, so line L, this line in the middle that's going up and down, is perpendicular to the line segment AB. So you can see they've already drawn in the right angle there. There's also a right angle over here on the right. All right, so if you want to draw that in, you can. If you want to draw in the right angle over there. All right, so the next part says line L bisects AB at C. Line L bisects the line segment AB at the point C. All right, that's really useful. That tells us that this line L is splitting AB in half, right? So that tells us that this little chunk over here, AC, is the same length as BC. All right, so those two pieces are congruent. All right, and then lastly, it tells us that the point P, so right here, the point P, is on L, okay? And we're supposed to be proving that PA is equal to PB. And remember, when there's no line above it, that's referring to the length of the line segment PA. Right, so if you see just PA written like that with no notation above it, that means the length of the line segment PA. All right, so we're trying to prove that the length of PA, the length of the line segment PA is equal to the length of the line segment PB. Excuse me. All right, so let's start here at the beginning. Line 1 says line L is perpendicular to the line segment AB and P is on L. All right, that was given to us, right? That was given to us in the beginning. All right, next we have angle ACP, so ACP, and angle BCP, so BCP, are right angles. Do you remember, why were we allowed to mark those as right angles? What was the little piece of information that we were given that told us that we could mark those as right angles? That was that part about them being perpendicular, right? So that's the definition of perpendicular. when two lines are perpendicular, they form a right angle. All right, so that's the definition of perpendicular. All right, next we have angle ACP is congruent to angle BCP. So ACP, which is that right angle, is congruent to BCP, which is another right angle. All right, so how do we know that? Do y'all remember the theorem from the last section that told us that right angles are always congruent? That was called the right angles congruent theorem. So the right angles congruent theorem. So make sure you have that one written down, have that theorem in your little toolbox. So that's what it almost always, the use of this theorem is almost always going to come after the line that says definition of perpendicular. So that'll be kind of like a little heads up. When you see definition of perpendicular, you want to think, okay, I'm probably about to use the right angles congruent theorem. All right, next we have line L bisects the line segment AB. Well, that was given to us. Remember, that was the little piece in the middle there. All right, so that was given. All right, let's look at the next line. Line segment AC is congruent to line segment BC. Remember, we had that marked up here. Why did we mark that? Why were we allowed to mark that AC was congruent to BC? That was the definition of a bisector, right? So a bisector splits things in half. All right, so that's the definition of a bisector. All right. Next line, line segment PC is congruent to line segment PC. All right, so I forgot to mark that, but they share this common side, don't they? Let's mark that. All right, so they share that common side, so let's mark that with a little congruent tick mark. And do y'all remember what property that is when you prove that something is congruent to itself? That's the reflexive property, right? And then next line. Okay, we're jumping to the triangle congruence here. So we've got to figure out which postulate are we going to use. Triangle ACP is congruent to triangle BCP. All right, so when you see that line where you're trying to prove, so here you're trying to prove that two triangles, well, I was trying to draw a triangle there. It looked like an A. When you're trying to prove that two triangles are congruent, remember the tools we have in our toolbox for proving that two triangles are congruent? That's those four postulates, right? So you're thinking of the four postulates. All right, so let's look at our diagram and see which of our four postulates we're using here. So here's our diagram. Just look at half of the triangle. I always mark out the one on the right. You don't have to do that. You can mark out the one on the left. But I just always mark off this one and try to hide this one. Okay. All right, so just look at this triangle on the left here. Let's see what we have marked. We've got two sides marked. We've got two sides and one angle. Is that angle the included angle or is it the non-included angle? That's the included angle, right? All right, so that's the included angle. All right, so if you have two sides in the included angle, that's side, angle, side. All right, that's our SAS postulate. There we go. SAS postulate. All right, now, remember what we said earlier, or what I said on the last slide. When you are doing proofs in this section, a lot of the times the way that they will work is the majority of the proof will be spent proving that two triangles are congruent, and then immediately after that you're going to be able to use that CPOC tack, remember? So you're going to get a lot of information after you prove that two triangles are congruent. You're going to be able to prove that corresponding parts of congruent triangles are congruent. All right, so let's look at what we're supposed to be proving here and just make sure that those are matching up appropriately. All right, so it says line segment PA is congruent to line segment PB. right? So there's PA, there's PB. They do match, right? So that's, if you were to fold this triangle in half, those sides would match up. All right, so we are allowed to say that those two sides are congruent by CPOC-TAC. And then the next line says the length of the line segment PA is equal to the length of the line segment PB. Now this is something that we haven't used in a while. We have not used this property, I want to say since the last chapter. But this property that allows you to say that the length of those congruent sides are congruent, it's just the definition of congruent, all right? So when two sides, when we say that two sides of a triangle are congruent, by definition, their lengths are equal. So the definition of congruent sides is that their lengths are equal. Right, so that says, if you can't read my handwriting, that says lengths are equal. And then for the definition of congruent angles, that would be that the angles are equal. Angle measures are equal. All right, so by the very definition of congruent, those two side lengths must be equal. All right, great job. I know that was a tough one. Let's look at one that's a little bit easier. All right, so let's look at our next proof. This one says complete the proof. You can see we have this diagram over here. It kind of looks like a diamond with, on each side we've got this, what we, suspect is going to be two congruent triangles. All right, so it says given that the ray, or actually in this case it does look like a line, doesn't it? So that notation seems to be messed up. All right, so the ray AB bisects angle CAD. All right, so CAD. Okay, so AB is bisecting CAD. So that means it's splitting this little angle up here in half. All right, so we can go in and mark that as congruent. Sorry guys, my little swooshies aren't very good. I'm using my mouse to write instead of my writing pad. Yeah, that's a little better. Okay, those two angles are congruent because AB was a bisector. Right, the second part that we're given says that BA, the ray BA, bisects angle CBD. Right, so CBD is bisected by the ray BA. So I guess they're thinking of these as two separate, this line, they're separating it into two separate rays. All right, so since CBD is being bisected, that's going to create two little congruent angles down here. So let me see if I can mark those as congruent. Okay, those are congruent as well. Now we're supposed to prove that angle 1 is congruent to angle 2. All right, so we're supposed to prove that angle 1 is congruent to angle 2. All right, so let's see their approach here. It starts, you can see we've got blanks on both sides, and we're separated again into statements and reasons. The first statement says, ray AB bisects angle CAD. Well, that was given to us. So that was given. Right, next, our statement is blank, and it says, by the definition of an angle bisector. All right, so if we're basing this on the statement that AB bisects angle CAD, then by the definition of an angle bisector, what do we know? We know that that created those two little congruent angles, right? So if AB bisects CAD, and we're supposed to be using the fact that by the definition of an angle bisector, that's going to tell us that those two little angles are congruent. All right, so let's name those angles. That's going to be CAB and DAB. All Right, so CAB is congruent to DAB. Right, so angle CAB is congruent to angle DAB. You could have also named that angle on the right BAD if you preferred. All right, and then the next line, kind of similar to what we saw in the beginning. Ray BA bisects angle CBD. Well, that was also given to us. That was part of what we were given. All right, and then once again, just kind of repeating the first two lines. We're kind of just, you see that little pattern there. We started, we had the given line, and then by definition of an angle bisector, and then given line, and then by definition of an angle bisector. So we can probably guess that this is going to be referring to those congruent angles at the bottom. All right, so let's name those. I would say that CBA and DBA. Right, so CBA and DBA. Right, CBA and DBA are congruent. Okay, and then the next line says line segment AB. That's that one in the middle. Line segment AB is congruent to line segment AB. What property is that whenever something is congruent to itself? That is the reflexive property. Now, we can also, because of this line, and we could have done this earlier, but I just didn't think about it, but we can go ahead in here and mark this little congruent tick mark, showing that that line segment is congruent to itself. Okay. That's just going to help us identify if this is, what postulate that we're supposed to use. All right, so speaking of what postulate we're supposed to use, here we are at the line where we're supposed to be proving that two triangles are congruent. And remember, anytime you're proving that two triangles are congruent, you're supposed to use one of your four postulates. All right, so we're supposed to be proving that triangle ACB is congruent to triangle ADB. All right, so let's see what postulate we're going to use, and I'm going to do just like we were doing on the last couple of slides, and I'm just going to mark this out. Right now, we're just looking at that triangle on the left. All right, so just looking at the triangle on the left. Let's see what we have marked. I see an angle and an angle, so we've got two angles, and we've got a side. Is that the included side, or is it the non-included side? That is the included side, right? So we've got two angles and an included side. So look at your definitions of your four postulates. Which postulate is for when you have two angles and an included side? That's angle, side, angle, right? Angle, side, angle. So by the angle, side, angle postulate, those two triangles are congruent. Okay, now, let me erase where I marked that off. There we go. Okay. So now our last line of our proof, remember our last line of our proof is always supposed to be what we were setting out to prove. All right, so what we were setting out to prove is blank here, that our statement is blank. And the reason that it gives is CPOC. So remember that stands for corresponding parts of congruent triangles are congruent. All right, so the last line of our proof should be what we were trying to prove, which was angle 1 is congruent to angle 2. All right, so angle 1 is congruent to angle 2. Okay. All right, let's look at one more. All right, so here we've got a proof. We've got this little figure over here at the right, kind of looks like a paper airplane. It says we're given that line segment AB is congruent to line segment AC. You can see that they've already marked that for us. All right, so they've already included those little tick marks to show that those are congruent. And then it's also given us that M is the midpoint of the line segment BC. So what is that going to tell us if M is the midpoint? Well, we get a couple of things, right? We know that the line segment AM must be a perpendicular bisector, right? So that's a perpendicular bisector. And it's also creating these two little equal chunks here. So we're going to mark those as congruent as well. By definition of the midpoint, those two little chunks are congruent. All right. All right, so let's take a look at our proof. All right, so we've got blanks on both sides again. All right, so starting off, we got line segment AB is congruent to line segment AC, and M is the midpoint of the line segment BC. All right, that was given to us, so that's easy. All right, then the next line, we've got the statement blank, and it says by definition of the midpoint. So remember, by definition of the midpoint, it told us that those two little chunks were equal. All right, so the midpoint means that it's exactly halfway in between B and C. So that means that line segment BM is congruent to line segment MC. All right, so BM is congruent to MC by the definition of the midpoint. All right, then the next line, we've got line segment MA is congruent to line segment MA. That's that common side in the middle there. We can also mark that as congruent. Let's put 3 tick marks on that one since we've already done 1 and 2. Let me try that again. Those looked a little far apart. I'll try to make them closer together. Okay. All right, so I'm sure y'all already know what the reason is for that one. When something is congruent to itself, what property is that? That is the reflexive property. All right, and then our next line, our statement is blank, but our reason is the side-side-side postulate. All right, so we have the challenge of we have to name these two triangles that are congruent, okay? So I want you to take a look at both triangles and pause the video and see if you can name them. Remember, when you name the first one, just kind of name it randomly. So I would name this one like AMB. Yeah, let's start off with that, AMB. So start off with triangle AMB and see if you can figure out what would the congruent triangle be on the right hand side. All right, and I chose A and B here because that was on the last line of the proof, was angle A and B. So I'm just kind of going off of their, you know, using their notation as a starting point. All right, so AMB would be congruent to AMC. So triangle AMB, we're starting with A, following the 3 tick mark side, then going on the 2 tick mark side, then back up the 1 tick mark side. So that's how I'm naming this. All right, so I'm going down the 3 tick mark side, then going across the 2 tick mark side, then up the 1 tick mark side. So that would be AMC. So triangle AMB is congruent to triangle AMC. And our last line says angle AMB is congruent to angle AMC. So after we use one of those postulates to prove that the triangles are congruent, how do we now know that all the other little angles and sides are congruent? What is that called? CPOC, right? Corresponding parts of congruent triangles are congruent. All right, so I want you to prepare yourself. This next proof, the diagram looks complicated, but I know you guys can do it. I want you to, you know, think about it carefully. Pause the video and take a few minutes and look at the diagram, kind of analyze it, and then we'll go through the proof together. All right, so here is, I would say this is our most challenging proof in this section. You can, like I said, I would like you to take a moment and just pause the video so you can review this diagram. Just take note of what sides and angles are marked as congruent, and just kind of think about how those are matched up and you know, which pieces are corresponding to each other. All right, so we are given that line segment TE is congruent to line segment RI. They have already marked that as congruent for us. And then it says that line segment TI is congruent to line segment RE, and those are also marked as congruent. And then it says that, angle TDI, that's that right angle, and angle ROE are right angles, and of course that's going to mean that they are congruent to each other by the right angles congruent theorem. Right, and then so everything is marked that we needed to be marked based on what we were given, and then we were supposed to be proven that TD, so that's that leg of that right triangle there, is congruent to RO, which is the leg of this right triangle here. Okay, so we want to prove that TD is congruent to RO. All right, so you can see it's a pretty long proof compared to some of the ones we've done already in this section. So we're just going to take it line by line. We'll talk about why this proof looks so long. And I also just want to point out that you see that some sides the blank is on the reason, some sides on some lines the blank is on the statement. All right, so let's take a look at our proof. Line segment TE is congruent to line segment RI, and then line segment TI is congruent to line segment RE. Well, that's what we were given. All right, so that was given to us. Next we have, so that's those two sides. Those are already marked as congruent. And then line segment IE, right, that's that diagonal right there. So line segment IE is congruent to itself. Right, what property tells us that something is congruent to itself? That's the reflexive property. All right, so I've marked these, I've highlighted them so you can see that we're looking at two little triangles here. So there's our first leg, here's our second leg, here's our first leg, here's our second leg. All right, so we've got a triangle on the top, a triangle on the bottom. All right, so we're supposed to be proving in this line that two triangles are congruent because we're using the side-side-side postulate, and the side-side-side postulate is used to prove that two triangles are congruent. All right, we need to name those triangles, right? But we can also use the next line as just kind of an indication of how we're supposed to name that. All right, so anytime you are working in a proof like this where you got blanks on either side, you can kind of use the next line to inform how you're going to fill in this previous line. All right, so we've got angle TIE is congruent to angle REI. All right, so let me mark those on our diagram. I was trying to use the highlighter. TIE is congruent to REI. Right, so those two triangles are going to be congruent by the side-side-side postulate. Note, we've got the side here marked, we've got the side here marked, and then we also said the IE was congruent to itself. I'm not marking that as congruent, although if you wanted to, you could, throw three little tick marks in here. Let me see. You could throw three little tick marks in here. It's just the diagram is already looks pretty complicated. All right, so notice that all three sides are filled in. Side, side, side. So all three sides have tick marks on them. So we're using the side-side-side postulate. And again, we were naming those TIE and REI. Okay? TIE and REI. Now the next line says angle TIE is congruent to angle REI. And what always comes after one of those postulates? So what is the theorem or the concept or the postulate, whatever you want to call it, that comes after the side-side-side postulate or the side-angle-side postulate? That is CPOC-TAC, right? Corresponding parts of congruent triangles are congruent. All right, let me erase all my stuff. Okay. So there's those two triangles. So by CPOC-TAC, those two angles are congruent. Now the proof from here seems to start over almost, right? So it's kind of starting over. And it says that we're supposed to be using something that was given. Well, we've already used the first two pieces, so let's use the third piece. So angle TDI and angle ROE are right angles. Okay. And by the right angles congruent theorem, what can we say is true? We could say that those two angles are congruent, right? So angle TDI is congruent to angle ROE. All right, next we have triangle TDI is congruent to triangle ROE. All right, so let's take a look at those two triangles and we'll figure out what postulate that we're supposed to use to prove that those are congruent. All right, so TDI and ROE. All right, so what did we mark? Okay, so we've already got an angle and a side. We also proved in line 4 that TIE, so that's this angle right, let me see if I can mark it. This angle right here is congruent to REI, which is this angle right here. All right, so now we've got another angle. All right, so let's figure out what postulate we're using. Let's ignore the bottom for right now. Just looking at the top. We've got two angles and a side marked. Two angles and a side. Is that the included side or is it the non-included side? That is the non-included side, right? If it was the included side, it'd be down here. So look at your definitions. What postulate uses two angles and a non-included side? That's the angle side postulate, right? All right, and then lastly, remember our last line of our proof is always supposed to be what we were setting out to prove, which is that TD, line segment TD, is congruent to line segment RO. TD is congruent to line segment RO. And that is true by CPOG-TAC. Okay. All right, so here we've got one that's a little bit different. It just says find and correct the errors in the proof. So they're giving you a completed proof, and they're telling you that there may be one or more errors in this proof, and we're supposed to find and correct those errors. All right, so here we have a little diagram. Kind of looks like a butterfly, kind of giving butterfly vibes. All right, and then we're given that KH, line segment KH, is congruent to line segment NH. That is already marked for us. And then angle L is congruent to angle M. That is also marked for us. Okay, and they share angle H, right? So angle H, that's a vertical angle with itself. All right, so those two angles would also be congruent. So I think I'm going to go ahead and mark those. I'll do two little swoopies. I'm going to try to anyway. Okay, well, I think that's about as good as it was going to get there. Okay. Now, what we're trying to prove, we're supposed to be proving that H is the midpoint of LM. Now, H is definitely the midpoint of KN, right? Because those two line segments are congruent, so we know that, but we want to prove that H is the midpoint of LM. So in order to prove that, we need to prove that LH, the line segment LH, so that chunk right there on the bottom, is congruent to MH, so that chunk on the top. All right, so let's take a look at the proof. Line 1 says line segment KH is congruent to line segment NH, and it says that was given. Well, that is, there's nothing wrong with that, right? So we'll just, if everything looks good, we'll just check it off, sort of verifying the proof. All right, so then it says angle L is congruent to angle M. That was also given to us, right? And they said given, so that's fine. Then it says angle KHL, KHL is congruent to NHM, right? And we had already marked that, so, and they said that's by the vertical angles theorem. That's fine. We did mention that those are vertical angles. All right, and then it says triangle KHL is congruent to triangle MHN. Right, so let me get rid of those. Okay. Triangle KHL is congruent to triangle MHN by the angle side angle postulate. All right, so let's look at our triangle on the left. Just ignore it. Let me try that again. I'm going to just pretty much ignore this triangle on the right, so don't look at it. We're trying to figure out which postulate we're supposed to use. Let's take a look at what we have marked here. We've got two angles marked and a side. Now, is this the included side or is it the non-included side? What do y'all think? That's the non-included side, right? So take a look at your definitions of your postulates. Which postulate is for two angles and the non-included side? That's supposed to be angle, angle, side, right? Angle, angle, side. But they have written here that that's by the angle, side, angle postulate. All right, so that is a mistake. So let's fix that. That's the angle, angle, side postulate. All right, they said errors, so potentially there could be more than one, so let's continue on. It says, now using CPOC-TAC, they are proving that line segment LH is congruent to line segment MH. All right, so let's make sure that those match up. LH, I'm just kind of looking at the order that they're written in the name. LH, MH, let's see. LH, that is the side that connects the two marked angles. All right, so that's how we'll make sure that it matches up. All right, so LH is the side of the triangle that connects the two marked angles. So is MH the side that connects the two marked angles? It is, right? So LH matches up with MH, so that works out by CPOC-TAC. And then the last line says H is the midpoint of the line segment LM by definition of the midpoint. All right, so they just told us that these two line segments are congruent by CPOC-TAC, and then by definition of the midpoint, since those two line segments are congruent, H must be exactly halfway in between L and M. So yeah, by definition of the midpoint, H is now the midpoint of line segment LM. All right, so only one error in that proof, but hopefully that just gave you a little break from having to, write the proof yourself, just kind of something different. Okay, so again, taking a slightly different approach in this problem, it says in the diagram, triangle PSY, so PSY is congruent to triangle SPL. All right, so based on that fact, your friend says that triangle PRL, that's kind of like the bottom leg here, is not congruent to SRY. Explain why your friend is wrong. All right, so if we're trying to prove that our friend is wrong, what would we need to prove? All right, so your friend is saying that these two triangles, PRL and SRY, are not congruent. So in order to prove that they were wrong, we would prove that they are congruent, right? So our goal here is to set out to prove that triangle PRL is congruent to SRY. And now that we know what we need to prove, let's set up this proof. We're going to have to write everything out. So what we're given, what we need to prove, and then set up the proof all on our own. All right, so we are given that triangle PSY is congruent to triangle SPL. All right, so if triangle PSY is congruent to triangle SPL, then the following information is given to us. First, angle P matches with angle S, right? And then vice versa. Angle S matches with angle P. So those two are congruent. Right, and then angle Y must be congruent with angle L. Right, and then vice versa. Angle L is congruent to angle Y. Right, now that we've taken care of the angles, let's do the sides. Right, so PS is congruent to SP, of course. So I'm just looking at the way the triangles are named. So PS and SP, those two are, of course, congruent to each other. And then SY, so that's the next part of the triangle name, PSY. So SY would be congruent to PL. Right, so that left-hand side is matching with the right-hand side. Right, so SY is congruent to PL. And then lastly, SL would be congruent to PY. SL would be congruent to PY. Okay. All right, so we've got a lot of given information. All right, so let's set up our proof. Okay, so we're given, like we said, that angle P is congruent to angle S, angle L is congruent to angle Y, and line segment SY is congruent to line segment PL, and line segment PY is congruent to line segment SL. That was all based off of what they told us at the beginning. Now, we're supposed to be proving that triangle PRL is congruent to triangle SRY. All right, so we're going to need to set up our proof. So go ahead and take a second and sketch out our little proof. You can see I put 6 lines on here and then an extra one at the bottom because I'm just not sure how long this proof is going to take. So I'm just, sketching out my statement and reasons, 2-column proof. And I may have to add more lines. I may not need this many lines. So we'll just have to wait and see. Right, so you may need to take a second, pause the video, and sketch this out. So go ahead and do that now if you need to. All right, so we are trying to prove that triangle PRL is congruent to triangle SRY. So we're going to have to pick out, we're going to have to look at what we're given and say, okay, we need to, pick out what are we going to be able to use here. All right, so the first thing that I'm noticing is that whenever you say that angle P is congruent to angle S, I don't think we're going to be able to use that because angle P is this whole angle here. So this is P and this is S. Right, but that goes into this little top part of the triangle, which we're not using as part of our proof. All right, so that's not part of the proof. So I don't think we're going to be able to use that first part of our given information, so I'm just going to mark it off. Don't worry about using that. All right, next we have the angle L is congruent to angle Y. All right, so that's this angle here and this angle here. Those do not, move into any other triangle. It's just this little angle here, this little angle here. So I think we are going to be able to use that. And then line segment SY. Right, so SY, that's the right leg over here, is congruent to PL. Right, so I think we're going to be able to use that. That doesn't, go into any other triangle. All right, and then lastly, line segment PY is congruent to line segment SL. So PY is congruent to SL. Yeah, I don't think we're going to be able to use that because that's really going across 2 triangles there. All right, so we're not going to use that either. So go ahead and mark that out. All right, so don't worry about using that one either. And I'm not marking those out because they're not true. They are true. It's just that it's not going to be useful for this proof. All right, so let's start with what we can use. I'm going to start with the line segment SY is congruent to line segment PL, but you could start with angle L is congruent to angle Y. So there's really no rhyme or reason as to why I did the line segment first. All right, so those two are congruent and that was given to us. And then the 2 angles are congruent, angle L and angle Y, and that was also given to us. All right, so you can see that I've went ahead and marked those as congruent on my triangles. All right, so remember to prove that 2 triangles are congruent, which is what our goal is here, right? We're supposed to be proving that triangle PRL is congruent to triangle SRY. To prove that two triangles are congruent, we use one of our four postulates. So side, 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 angle, angle, side, or angle, side, angle. All right, so we've got to figure out which postulate that we're going to use here. Right now we only have two things marked, so we do need one more. We either need another side or we need another angle. All right, so what do you think here? Do you see anything else that's matching up in these two triangles? It's angle R, right? Angle R is a vertical angle with itself. So it's, you know, when we had that vertical angles theorem, which said that when two lines intersect, they form two pairs of vertical, or two pairs of congruent angles, right? So there's these angles on the top and bottom, and the angles on the right and the left. All right, so angle R is congruent to itself. All right, so we're going to call that angle R. And that's the reflexive property, but also the vertical angles theorem. So I'm going to add that in there as well. So that's the reflexive property, but it's also the vertical angles theorem. So we'll say and vertical angles theorem. All right, so let's mark that with our little congruent tick marks. All right, so now we've got three things marked. So I think we can, you know, jump to our congruent statement, our triangle congruent statement. All right, so triangle PRL is congruent to triangle SRY, and what postulate is that? So we've got two angles and a side. Is that the included side or is it the non-included side? That is the non-included side, right? So the included side would be over here. So this is the non-included side. So look at your definitions. Which postulate uses two angles and a non-included side? That is the angle side postulate, right? So we have done it. We have proved our friend wrong. With this 4-line proof, we didn't need those extra 2 lines. So we'll just go ahead and take those extra lines off, and that's our finished proof. All right, so number 10, we've got this diagram. It kind of looks like a kite to me. And it says we're given that angle 1 is congruent to angle 2, which they have already marked, and angle 3 is congruent to angle 4, which they have already marked. And we're supposed to be proving that triangle QET, which is that, looks like a right triangle right there, is congruent to QEU. Okay. All right, so let's look at our proof. We've got blanks on both sides. Line 1 says, oh, and this is our first proof, I think, where we have one line completely blank. So we've got line 2 is completely blank and line 5 is completely blank. All right, so line 1 says angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. All right, so that is what we were given. All right. So let's take a look at this line here, line 3. That's going to inform us of how we should fill in line 2. All right, so line 3 says triangle QTB. That's QTB up there at the top. QTB. Oops, sorry. QTB is congruent to triangle QUB. QUB at the bottom. Okay. And we have a blank line. Now, what do you see that just overlapped in those two triangles? That's the line QB, right? The line segment QB overlaps in those two triangles. All right, so using, what property do we use to say that this line is congruent to itself? All right, so that's line segment QB is congruent to line segment QB, and that's by the reflexive property. All right, so we're just pointing out that they share a side. Right, so we're just pointing out that those two triangles share a side. That's going to make this line, or this line segment congruent to itself. All right, and now they're jumping to a triangle congruent statement. All right, so that means we're supposed to be using one of our 4 postulates. All right, so what postulate do we use here if we have two angles and an included side? Two angles and an included side. That is the angle side angle postulate, right? All right, and then the next line says we're supposed to use CPOC-TAC. All right, so CPOC-TAC to prove that something is congruent. All right, so let's think about what would we need to prove is congruent at this stage. Well, in order to figure out what we need to prove is congruent at this stage, I guess we really need to look ahead and think about what are we going to need to know. All right, so what are we going to need to know if we've got to prove that triangle QET is congruent to triangle QEU? All right, so let's see. It would be useful to know that these two sides are congruent, right? So it would be useful if we knew that QT was congruent to QU. Do we get that for free based on line 3? Is that true based on line 3? Yeah, for sure, right? So QT matches with QU. All right, so line segment QT is congruent to line segment QU. All right, now what about this blank line in the middle? Last time we had a blank line in the middle, we used reflexive property. I think we're going to do the same thing here. These two triangles, QET and QEU, they share a side. All right, so that side in the middle. And what is the name of that side? That is line segment QE, right? So line segment QE is congruent to itself based on the reflexive property. All right, and then let's mark that as congruent. Let's just do two little tick marks there. Okay. Right, so let's take all that away and let's mark what we know is congruent. So I'm just kind of making my diagram a little bit more clear. Right, so we know that line segment QT is congruent to line segment QU. We also know that QE is congruent to itself. All right, that helps a ton. Now we can see what postulate that we're supposed to use. All right, so we've got here, let me block off one of these. Let me block off this one at the bottom. And then this over here. All right, so just look at, and if, of course, if you're doing this on your own paper, you can just cover that up with, you know, your hand or cover it up with a couple of other pieces of paper. You don't have to actually mark it out. All right, so let's see what postulate we're going to use. We have two sides and an angle. Is that the included angle or is it the non-included angle? It's the included angle, right? It's the angle that is in between these two sides. All right, so look at your definitions. Which postulate uses two sides and an included angle? That's side, angle, side, right? We haven't used that in a while. Side, angle, side postulate. All right, let me get rid of that scrabble, as my kids call it. We're finished. You guys did it. I am so proud of you for watching this whole video and sticking it out and doing something that is hard, and I know that this is challenging, but you're going to get better at it the more you do it. So go work on the homeworks. Allow yourself to struggle with them. You know, you might have to come back 3 and 4 times to complete this homework assignment. That's okay. You know, keep watching the video over and over. So find the proof in the notes, in the guided notes that looks the most like the homework problem you're struggling with. Then go to that part of the video and rewatch that video, or rewatch that part of the video. I know that you guys can do this. I'm so proud of you. And if you have any questions, please let me know. I'm happy to help you, give you a hint, or let you know if you're on the, heading in the right direction, or even just let you know if your proof looks correct. All right, so let me know if you have any questions, and I'll see you guys next time.